Hey everyone, we're back with more calculus. This time we're going to take a look at the question about the woman pulling a boat into a dock. Let's not waste any time and get right into it. We've got a rope attached to a boat at water level and a woman on the dock pulling the rope at a rate of 50 feet per minute. The woman's hands are 16 feet above the water level. How fast is the boat approaching the dock? So we're talking about speed. We see a rate over with 50 feet per minute. So that makes me think that this is a related rates question. So we're going to follow that routine. Now, the first thing to do is to get an understanding of this question, which hopefully with my drawing over here, you guys have an idea about what's happening. Now, remember that the rope is going in. Okay, so whatever rate we put here, that's going to be negative since that length is decreasing. And like so many of the problems, the trick here is to look at this as a triangle. So here is our triangle. Okay, it is a right triangle. Now the rate or the vertical drop here, that's going to be, well, let's label that y. And then the distance from the boat across, we're going to label that x. And if we got an x and a y, we should label this part z. And let's make our diagram a little bit free from context here. That'll make things easier to take a look at. Now, if only we had some kind of a relationship for a right triangle that relates x, y, and z. Oh wait, there is. It's the Pythagorean Theorem. It's x squared plus y squared is equal to z squared. With that mathematical model, we have the opportunity to ask, are any of those segments constant? And actually, y is constant. The drop of the rope is always going to be 16 feet. So we'll just rewrite that in terms of that constant. From what we know about boats, or what you may not know about boats, is if z is decreasing, then of course x has to be decreasing as well. So we're looking for negative rates for both x and z, which means negative derivatives. Nothing else is constant, so the next step here is to take the derivative of everything with respect to time. So the derivative with respect to time of x squared plus 16 squared is going to be equal to the derivative with respect to time of z squared. Taking a look at the variables, we notice that we're taking a derivative with respect to t, and that's a mismatch with the variables that we are given. So we're going to use the chain rule to take the derivative of this. So the derivative of x squared with respect to t is the derivative of x squared with respect to x, which is 2x, multiplied by dx dt. The derivative of 16 squared is 0. And just like the derivative of x squared, the derivative of z squared with respect to t is the derivative of z squared with respect to z, 2z, multiplied by dz dt. Okay, some really quick simplifications. X dx dt is equal to z dz dt. Okay, and gosh, I don't have a value for x. I don't have a value for z. No, I do have a value for z. The amount of rope out is 20 feet. I have a dz dt. I don't have a dx dt. So I'm going to have to figure out one or the other either x or dx dt. And luckily, the Pythagorean theorem is going to allow me to figure out the value for x. So we got x squared plus 16 squared is equal to 20 squared. That's the way things currently look. And if you solve that, you get x equal to positive and negative 25.61249. Of course, this negative root is not in the domain, so the only one we're going to worry about is 25.61249. Now we can substitute all of that in there. We get that 25.61249 multiplied by dx dt. That's equal to 20 multiplied by, and remember, dz dt is a negative rate. And when you solve this, you get, and whoops, I made a mistake with my Pythagorean theorem. Actually, this is going to be, what number did I get? I got 12, right? Yeah, I got 12. Basically, that's just bad math on my part. So negative 12, again, not in the domain. And then positive 12 over here. So this right here is 12. And this right here is negative 83 1/3. There we go. That takes good. Sorry about that if you were freaking out like 2 minutes ago. I was also freaking out 2 minutes ago when things weren't working out right for me. So here is our response. Let's go ahead and write ourselves a nice summary. So when 20 feet of rope is out, the boat is heading into the dock at a rate of 83.333 feet per minute. So that's our boat problem. Sorry about that little mistake there at the very end. It happens. So I'll see you next time when we look at more free response type questions for your Chapter 5 calculus test.